Maybe you, David.
Wow. Alright. I know. Alright, crazy. Quiet, please. So, we have talked a little bit about this, like in the packet from yesterday. It asked a couple times, what would you expect to get, or what would we predict? So I'm going to go through, and this is our equation. Oops. Kind of circled the middle of it. That's what we're working with. And I want to fill out, so the person in our data that had an IQ of 100 got a 21. I want to fill out what the equation would have predicted them to get. So how do I do that? Plug 100 in for IQ. So I'm going to go 0.163 times 100 plus 4.2. So they would have been predicted to get a 20.5. So make sure you get the same thing I'm getting. It's not possible, but that's okay. Like our predictions can be kind of an average of like what we'd expect. So you're right, you can't get a 20.5 in the ACT, but that could still be like on average what we think you'll get. If you took it 1,000,000 times, we average them all together, you could get 20.5 on average. So did this person do better or worse than we expected them to do? They did better. So the residual is the difference between what they did and what the line predicted them to do. So it's actual minus predicted, which I just remember, like, we're in AP Stats, right? So actual minus predicted, that's the order you do it in. So the actual score was 20, the predicted score was 20.5, so that person's residual was 0.5. A positive residual, I'm just subtracting the actual 21 minus what we expected. 20.5, so I get 0.5. He did. He or she. We predicted that the line predicted that the person would get 20.5. Yeah, like backwards. So if I graphed this data, would this 21 be above our regression line or below the regression line? It would be above it. So a positive residual means higher than expected and above the line. Should I write out what negative means too, or can we understand that? Okay. So let's keep going. Excuse me, let's keep going. So if I do the next person at an IQ of 120, so 0.163 times 120 plus 4.2, 23.76. So did this person do better or worse than we would have predicted them to do? Ooh. They did worse, didn't they? So positive or negative residual? Negative because they did worse. Would we be above or below the line? We would be below. So the residual here would be negative 0.76. You do the actual minus the predicted. AP Stats. Actual minus predicted. So I want you to go through and fill out that whole chart. What did you say? Do you want a second to like whine about it before you do it? Someone said, well.
It's just a lot of money.
Right, so that's what I'm saying. Do you want a second to like, to whine first? Trying to be nice. I didn't think I gave you that many points. So that's what I got. So compare yours, see if you made some, or maybe I screwed up, I don't know. So let's see if they're the same. And then we're going to graph those. Talk about the graph a little bit. Yeah. Yep. And this should be negative. We're not graphing yet. How do we match? We good? You guys done with us? Okay, so now I want to make a residual plot. So I left you room for that on the bottom. Along the x-axis, we are going to put IQ. And the range for so the lowest was like 70, the highest was 150. So I'm going to start at 70 and go up by tens. And then on the y-axis, we're going to put the residuals. So you're going to write residuals along the side. And you're going to graph the residual that goes with each x value. So I'll give you a second to draw that, and then I'll go through a couple with you. So you're graphing the residual. So you're, like this 100 is the x value, and the y value that we're going to graph is 0.5. So I'm going to put a point at 100. So I guess I should go on the side and go like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Go down. And then at 100, my residual was 0.5. So we're above the line. Did this person do better than we would have expected them to do, or worse? We did better. If we got a positive number above the line, then they did better than we expected. 120, we got negative 0.76. So that person did a little bit worse than we would have guessed that they would do, or predicted, or expected they would do. 150 is 3.35, so that person did quite a bit better than we would have guessed that they would do. You guys see what I'm doing? So the 88.46. So they did a little bit better, but pretty close to what we would have guessed. 95 is negative 0.685. 130 is negative 5. Come on in, thank you. $85 is 4. 140 is 1. 70 is negative 1.6. Thank you. 135 is negative 0.2, so pretty close to 0. And I want you to see, I don't know if I can show these both at the same time, but the residual graph is basically, if I were to graph the data, the data looks like that. Well, if I just turn it, do you see how that's basically the same exact thing? And that makes sense, right? If it's above the line, these points up here, do they have positive or negative residuals? Positive, and they're positive by the amount that they are away from the line. So, like, this has a pretty big positive residual because it's way above the line. Well, that has a pretty big positive, it matches up. So this is our lowest one that's pretty far below the line. And that's this point down here if I move my calculator out of the way. Right? So, if the residual plot looks like this, where it's kind of scattered and there's no definitive curved pattern, this is the next part of this. If there's no obvious curved pattern, that means a line was a good choice for our data. That means our data is linear. I'll write this down on the next page. But let me give you an example of where it wouldn't be. And you don't have to type this data in, but I want to show you. This will take me a second if you want to talk amongst yourselves. Yeah. Okay, this is an example of when the residual plot would not give us randomness or scattered. This light is really quaking me. Good Lord. But then you won't be able to see it.
Wow, that's a good.
Really an idea, thanks.
It's fine.
There, that's okay. Okay, so if I made this residual plot, we can kind of sketch what it would look like. I mean, here. That would be the residual plot, right? Like if I just turn it sideways, that's the residual plot. Do you see how that's not like a random where you got some above and some below, but there's an actual curve there. You guys see what I'm saying?
Yes.
If there's a curve there like that, that means your data is not linear. So random scattered residual plot, data is linear. Curved pattern, data is not linear. Does it? So go to the next page. Let's just write that down, basically. So what does it mean if the residual plot shows a curve? Data is not linear. So your data could be like x squared or e to the x or exponential or like all these different things. It's just not a line. What does it mean if the residual plot shows randomness or no pattern? Data is linear. So they probably do that on Khan a lot. They give you stuff and ask you if it's linear. Okay. So does that help with that? All right. Okay, what does it mean if the residual is positive? So we did better than expected. And where's the point? Above or below the line? Point is above the line. So above the LSRL or above the regression line or above the line. Whatever. And then what does it mean if it's negative? It'd be the opposite, right? So we did worse than expected. Point is below the regression line. So I want you to try. What? You gotta raise your hand. You gotta get longer arms or something. Yeah.
On Khan.
Yeah.
Always And then it says, like, did it underestimate or like overestimate the point?
So if we're above the line, if the point's above the line, then the line underestimated where we would be.
Yeah.
You know what I mean? Like it's the opposite kind of. Any other questions on this or on how Khan asks it or whatever? So this next one is just, they can ask it kind of two ways, so I'm just trying to practice both of those ways. So here's your actual equation up here. It's in bold. I put a box around it. Hopefully you can see it. So if the actual test 1, so this is like different rows of problems. I don't know if this is hard to read or not. But I just want to make you think about it backwards and forwards, basically. So if the actual test was a 90, and I can predict test 2 based on that. So if I plug in 90 here, so test 2 is, what am I missing on that test 2? There's something there I'm missing that's bothering me. A hat, right? This should be predicted. I guess I wrote predicted, so that kind of covers it, but I want a hat there. So 0.95 times 90 plus 10. So the predicted score on test 2 would have been a 95.5. That person got an 89. So like Khan would say, we overestimated. Or we could say the person did worse than we thought. But the residual is the actual score minus the predicted score. AP Stats, you're in AP. So you do the actual minus the predicted. Is your residual going to be positive or negative? It's going to be negative 6.5, right? So for the next one, 0.95 times 80 plus 10, the predicted score would have been 86. So now I'm making you find the actual. I'm just kind of flip-flopping that in your brain. So if the residual is negative, the person did worse than we would have thought, right? And they did 5 worse than we would have thought in this case. We thought they'd get an 86, so that means they actually got an 81. See what I'm doing? So finish that bad boy. And then when you're done, at the bottom, I want you to make a residual plot. So just like we did on the front page. Let's make sure we're the same here. And then at the bottom, I want you to make a residual plot like we did on the first page. We'll see if we get a curve pattern or a linear pattern or what. Yeah, that's the X value. So Yeah, so on the residual plot, you're putting the x value on the x-axis. So the x value in this problem is this test 1 right here, right? So that's what goes down here is test 1. Not always. So you gotta look at the equation to see that more than the table. So remember you're doing the x value and then the residual. So like my first one is a 90, test 1, and a negative 6.5. 80 and negative 5. So it should look something like that for your residual plot. You guys getting something similar? I mean, it's probably not going to be exact, but is that a clear, obvious curved pattern, or is that pretty scattered? It's pretty scattered, so is the data linear or not? It is linear. So scattered residual plot means the data is linear. So like if I graphed this line, it'd be a diagonal line that would kind of look like that, with some points above and some points below. So this is a scattered residual. Data is linear. What are you doing, Michael? What are you doing in the calculator? I just made up the stuff, so I'm not sure it's actually like the correct line. Yeah, it might not be accurate. I just was making up so we could do the question. Yeah.
What would it look like then if the data was like no association?
So, yeah, when I say curved pattern, I mean like a clear curve. Like you'll get a residual plot that looks something like that. Like, is that scattered or is that a clear curved pattern? That's a clear curved pattern. So what do we know about this data? It's not linear. So it'll be pretty obviously like a U or an upside down U.
No, but what if it's no association?
Oh, like it's not linear, or it would still be scattered actually.
So how can you tell? How do you tell though that it's
You can't. Then you'd have to to know if it's linear or not. You'd have to go back and look at like R and R squared. So we have like other pieces of the puzzle we would look at in that case.
not gonna get one that
I can't give you that and say is it linear or no association. I could give you this and R equals 0.8. Now is it linear or no association? Now you can say linear because that's a strong relationship. But if I said like, I give you this and R equals 0.01, then you can say no association. So you need more information at that point. All right, any other questions on this piece here? All right, I'll do a few of these with you. This is your homework. I'll do what we can do right now with you. Kind of get you going. Yeah, I didn't know how to type that symbol, so it's Y hat. So if I look at that first one, Y hat equals 3x plus 10. I've got a data point at 2, 5. So what is my actual y value? 5. So the actual data point is 5. How do I find my predicted y value? Plug 2 into here. So y hat would be 3 times 2 plus 10, so that would be 16. The residual is A minus P, because you're in AP Stats. It would be 16 minus 5. So 11. Would that point be above our line or below our line? It'd be above. Oh, wait, that's backwards. Actual's 5, predicted is 16. I'm sorry. Yeah, my bad. All right, so the residual is negative 11. Are we above the line or below the line? We're below the line. This person did better or worse than we expected. Worse. Now let me rephrase it. The regression line overestimated this person or underestimated them? Overestimated. So that's how Con phrases it sometimes? Is that what you're... Oh, okay. All right, let's look at the second one. So I'm giving you just kind of different information in these to make you manipulate it a little bit. So the residual of an x value of 3 is negative 5. So you know that residual equals actual minus predicted. I gave you the residual. Actual is what we're looking for. I'm saying what's the y value of the data point? And I can find predicted, right? So there's 3 things in this equation. I'm going to give you enough information to find 2 of them, and you've got to find the third one. So the predicted, well, my x value is 3. So what's my predicted? Negative 5. So I can use my formula, I can just kind of think about it. If my residual was negative, if my actual was negative 5 and my predicted was negative 5, what is my residual? 0. So if you solve that equation, you'd get that also. So that person did exactly what we would have predicted that they would do. I said they'd get a negative 5, they got a negative.
Which is 8 plus 5, and then you subtract this and you subtract 5. Because 2 minus is equal to positive.
God dang it! Yeah, you're right. No, I messed that one up too. That's not 0. So okay, look at the math. I was mixing up my data point. So this is plus, right? So then what's A equal? Negative 10. So that's the actual is negative 10. So okay, the residual was negative 5. The predicted was negative 5. So they did 5 worse than we predicted. We predicted negative 5, and they did 5 worse than that. So that's negative 10. Do you want to teach the rest of these, or should I keep going? You want to try?
Yeah.
Someone's already caught 2 of my mistakes. We should probably do one more. I need to get one right. So that'd be what? The over or under is based on the residual, and the residual is negative 5. So we are below the line, which means the line overestimated. Those are saying the same thing. So let me try again. I need to get one of these right. Alright, residual of a data point 10, 90. So the predicted value, I'm going to go 10 times 10 minus 5 equals 95. So residual equals actual minus predicted. What's the actual y value here? 90. What's the predicted y value here? 95. So what's our residual? Negative 5. So are we above or below the line? Below. So then rephrasing, did the line overestimate or underestimate? Overestimate. Should we do one more? Not doing all of them. So I'm just going to go outside first and write this residual equals actual minus predicted. They're giving me the residual is 10. I know, right? The actual is what I'm looking for. And how do I find the predicted? I plug it in. So y hat is going to equal -5 times, what am I plugging in? 5, because that's the x value, plus 8. So that's -17. Which should be a plus 17, right?
Yes.
So then the actual would have been -7. So that's alright? I know I screwed up the first couple, but I want you to keep going. Like, I want you to do some on your own without me talking. Partially because I screwed half of them out, but partially so you can do them on your own. I mean, I'll do them. I'll put answers up here, but... Ooh, they got easier. The next two are easier. Did you look at them yet? No, there's not even a residual involved. It's just what's the predicted value. You just plug it in. What's up? Oh, yeah, you can skip the last one. That's fine. I didn't give you enough. I could give you the information, I guess, but I feel like I'm confusing people. Here's the answers for those. So we'll practice more of this on Monday. I'll give you a warm-up with basically these type of questions on Monday so we can hit it again. And then we'll start doing frappies and AP practice questions and review and all that. Test will be Friday. Questions? All right. The last one you can't do. I didn't give you enough information. Sometimes. I feel like once every. No, I should do something. What's up? I'm done though. What's up?
Nothing, I was just seeing.